Okay, so let's do a brief demo on how we can complete problem 3.5. This is going to operate under the assumption that we've already done most of this in class. Taking a look at part A, we want to figure out what information do the y-intercepts give you? And in order to answer this question, the first thing you need to ask is, what is the y-intercept? Now, we've been working with the form y is equal to mx plus b, or if you put it into real words, we have the dependent variable is equal to the rate of change times the independent variable plus the y-intercept. And you might realize that we also have them in different forms, and especially for this one, the expenses, you'll see is not in the form y is equal to mx plus b, but rather the other way around. We would have y is equal to b plus mx, which is very similar. But because we have the y-intercept is the thing that you're adding independently, in this case, the number that you're adding by itself, that is your y-intercept. Y-intercept for your expensive is going to be 825. And on the other hand, if you take a look at the income, there's nothing being added at all. You might want to think about it like y is equal to 8.20 n plus 0. So your y-intercept for, for I is really 0. And one of the things we talked about with y-intercept is that it's basically the starting amount, the initial quantity. In the expenses, this is telling us it costs 825 before we've even started making any cakes at all. So that answers the first questions. We have the y-intercept, the starting amount is 825, and the income means you're starting with 0. If you take a look at A2 now, the coefficients of n, and as we see on our word wall, the coefficient is basically a number multiplying a variable. In this case, we see two numbers, 8.20 and 3.25, and each of these represent one of two things. You can say it represents a rate of change, or it can represent a unit rate. And to specify on the unit rate, this means one cake costs 3.25 to make, and one cake also brings $8.20 in profit. So now we're done with part A. Let's get rid of this. All right, and now we want to move on to part B. Fabian sells 100 cakes in January. We have two equations. Let's copy them down. E is equal to 825 plus 3.25 times n, and I is equal to 8.20 times n. And we want to figure out what are his expenses and his income. The key thing to note over here is that it says 100 cakes. Well, what does it mean if we have 100 cakes? Earlier on, it says for selling n cakes. So what you really want to do is, oh, if this says n cakes and this says 100 cakes, then the connection to make here is that n is equal to 100. So at this point, what you want to do is basically substitute in everywhere you see n, you're now going to replace it with 100. If we take a look at our expenses equation, we can see that there is an n here. So we're going to remove multiply by n and instead change it to multiply with 100. Let's just undo that real fast so we can see what we did once again. The original equation says 3.25 times n, so what we really want to do is erase our n and put in multiply with 100. So if we're going to do exactly the same thing on the other side, replace our n with 100, and since because they were connected with multiplication, it is still 8.2 times 100 and 3.25 times 100. Okay, so I guess this requires us to now use a calculator, or we can just do it by hand. 100 times 3.25 is 325 plus 825, and this is going to be our expenses. So we know our expenses will cost, add these two up, and that should be, that's 50, 1150. And because these are expenses, dollars. Okay, and let's quickly do the income. Same thing, 100 times 8.20. Same thing as moving the decimal place over twice. Income is $820. And then the second question is, what's his profit? And we already know we can calculate profit by taking your income, subtracting the amount that you have to pay, which would give you our profit. So we know our expenses are 1,150. We know our income is 820. So what we have to do is substitute in those values. 820 minus 1150, and I believe this gives us negative 330. Okay. I could be wrong on this one, but I'm not going to go too in depth into it. Okay. Let's take a look at B3 now. Explain how you could use this graph to determine Fabian's profit. Now we already said the profit is calculated by taking the income and subtracting your expenses. So if we take a look at this graph over here, one of the things you might want to figure out is which one of these lines represent income and which one of these lines represent your expenses. Taking a look at the two equations, and let's highlight this in yellow. We have expenses is this equation, and the income is this equation. In order to figure out which of these lines represent each of these equations, we really just have to take a look at some of the key features of this equation. For example, you can compare the rate of changes. If you compare the rate of change, 3.25 and 8.20, you should remember that if you have higher rate of change, this means that the line will be steeper. Taking a look at this, you can easily tell the pink line is steeper, and therefore that means this is your line for income. I is equal to 8.2n. The other way you might want to take a look at it is take a look at our y-intercept. Many of us remember from our first definition that the y-intercept is basically where it crosses the y-axis. In this case, this equation says, oh, the y-intercept is 825, and this is approximately 825. So now we know the other equation. This is your expenses, which is 825 plus 3.20n. Okay, and this is something that we did a little bit with today. How can we calculate the profit. Since we already had, oh, profit is equal to your income minus your expenses, you can basically do the exact same thing, but this time with the entire equation. For example, if you had, oh, wait, never mind. If I had I is equal to 8.2n and I had E is equal to 8 to 5 plus 3.2n, you can subtract these much like you would subtract anything else. Subtracting the E, which means you have to subtract this entire piece. So you know I subtract E is equal to 8.2n minus 825 plus 3.2n. And another way that you could rewrite this is actually 8.2n minus this. Subtracting a sum is the same thing as subtracting each of the individual pieces, also known as the distributive property. 8.2n minus negative times 825 minus 8 to 5, and once again, distribute here to the next part, and we will get minus 3.2n. And because these are on the same side, we can actually combine these two. 8.2n minus 3.25, is that correct? Minus 3.25, and you would be left with 4.95n, because remember, if you had 8 apples minus 3 apples, you would still have 5 apples. By the same logic, 8n minus 3n is about 5n. And because nothing else in this equation changes, minus 8 to 5. And this is going to be I minus E, which you already know is the same thing as P. And that's basically where this equation comes from. It's derived from taking away the equation that represents income from the equation that represents your expenses. And now we have some new questions that we talked about today. The break-even point. Instead of calculating profit, where you take income, subtract your expenses, what you're going to do now is you want your expenses to be equal to your income. We already know our expenses is equal to 825 plus 3.25n, and we know our income is 8.2n. So if we were to just do a little bit of shading over here, so if E is equal to I, we basically have this green thing is equal to this blue thing, which is equal to this green thing and this blue thing. So naturally, we would want to set these two circle things together because this is still E and this is still I, so they would still be equal to each other. And in order to solve that, you would basically write 8 to 5 plus 3.25n is equal to 8.2n, like so. Now, it's really important. In this case, we're looking for a break-even point versus trying to calculate profit. Each one of these are very similar, but how you set up the equation is slightly different. You could be quizzed on either tomorrow. Okay, let's skip over this one for a little bit. And now let's take a look at this. How many cakes can Fabian make if he wants his expenses to be less than $2,400 a month. So this is an equation that deals with expenses already, and we know the expenses are equal to 825 plus 3.20n. Because it tells you 2,400 are my expenses, the common thing you might want to ask yourself is, what variable am I going to be replacing with that? Remember, in an equation, you can only replace a variable. So what I have highlighted in purple, you are not allowed to touch. And when you replace a variable, typically speaking, you would only replace one at a time. Okay, let's redraw this. I believe this is 8.25. So in this case, we are actually going to replace the expenses with 2,400. 2,400 is equal to 825 plus 3.25n. And basically, this is how you're going to solve it. You're going to use inverse operations in order to solve for n is equal to something. And if you need really more help with this, please take a look at the other video that I have uploaded. On the other hand, we can do a very similar example. Income is greater than $2,400 a month. We know the formula for income is I is equal to 8.20 times n, and 2,400. This should be representing your income. So once again, we're going to be replacing it. And let's actually solve this one. Let's pull up my calculator. So if we know 2,400 is equal to 8.20 n, the inverse operation would be to divide it by 8.20. Divide this by 8.20. So we would have 2,400 divided by 8.20, and we should get something that looks like this. N is equal to approximately 292.68, or we would just say 292.7. So if we make 292.7 cakes, we will make exactly $2,400. If we want the income to be greater, well, then we should make more cakes. 293, 294. So pretty much anything greater than n is greater than 293. Exercise 4 is really more of the same. And that's pretty much it.